Hello, in this video I'm going to present you my digital design term project for EE102 course. For the course project I decided to design a device that both would allow me to develop my digital design skills and VHDL coding skills, and at the same time would be a useful device. Therefore, I decided to design a portable environment measurement device that measures environmental values such as relative humidity and temperature. And here is the device that I came with. My project consists of two parts, in fact. The digital design and the physical design, as I call it. I first started with the physical design in order to design a portable sensor device. The components I used are DHT22 environmental measurement module, a character display 2x16, my basis 3 FPGA board, and in order to make it portable I also used the lithium-ion battery with 7.4 voltage and a power regulator circuit to be able to connect it to the basis 3, which works with 5 volts, and also a flash drive to program my device without the need of a computer. First of all, let me introduce you my power circuitry. Although it's not the topic of digital design, it allows me to run basis 3 without being connected to a computer. This allows great flexibility. It consists of simply a LM2940 power regulator. This part, that one part, it's connected to the battery from the input. It's parallel connected to capacitors to compensate with the voltage fluctuations. The battery input is connected to a switch, and the whole circuit is connected to the output, which is connected to the basis 3. The sensor module and the character display modules are connected via the PMOD ports of the board, and they are given 3.3 volt voltages. Although my physical design worked without any problem, the coding part was much more difficult than I had expected. I coded the sensor and the code works somehow, but it works with errors, and the sensor doesn't respond with the correct values, and it almost gives values that does not correspond to real values of the environment. And also the character displays VHDL code doesn't work. Let me show you the codes that I've written. This project at the front is my actual project, but since its code does not work very well, I designed the second project that only communicates with the sensor and ignores the rest of the components. But first, let me explain the real project. My project design consists of modularly designed VHDL code. At the top of the code, there's this device module that connects other submodules and manages them. Under of the device module, there are my submodules. The most important one is sensor controller that communicates with sensor and interprets its outputs. Its code is written according to its datasheet. It's rather sophisticated and is also is a serialized code. Although its test bench actually works fine, the actual code doesn't always give true outputs. If we assume that it works perfectly, it outputs its values to the register sensor data register module. It's a simple input enabled 40-bit register. Then its data is processed in a data process module that it is converted from binary to binary coded decimal to be able to display it. Then a character display control uses this BCD data to send corresponding values according to the character display's datasheet. And an open source LCD controller that I downloaded from the internet was supposed to work and communicate with the character display and turn it on. Although most of the code didn't work as intended, first let me show you the simulation results. It was supposed to be here. I am sorry, there was a problem with the simulation. I am relaunching it because I turned off its window. While it's relaunched, it takes some time. I want to show you my actual results. As I told you, I didn't run the actual code, but run a test code that at least simulates, not simulates, but shows how sensor works. I downloaded its bit file to this flash drive to launch it without a computer. Let me attach it. As you can see, the jumper locations are changed in order to make it work this way. First, I turn on the power regulator switch. I put this switch because I didn't want to disconnect battery every time. Let me turn it on. And when we press the programming button, it's supposed to work. By the way, I disconnected the character display because its code already doesn't work and it consumes a lot of power. It launched. As I said, the sensor's data is actually meaningless. It sends some data, but when you convert this 16 bits, it corresponds to the temperature data. By the way, when you turn this switch, it shows the relative humidity data, and when you press this middle button, it shows measurement error and parity errors. And this relaunches the sensor. It takes some time to registers to change, and sometimes it doesn't work. Because when the process is not complete, the registers are not changed. Therefore, and since it completes sometimes and sometimes it doesn't, we can actually relaunch it. Yes, now the result is changed. As I said, the results contradict with each other and contradicts with the real world results, but at least there's a communication, and at least I assured that the sensor works somehow. Although my project is not complete, I learned a lot while writing VHDL codes for the sensor. I learned how it really works and how it's different from high-level languaging. I have some ideas about why my project didn't work as intended. It might be because of the wirings or because of a flaw in my code that doesn't show itself in the test bench. However, even though my project is not complete, this assignment allowed me to develop my coding skills, and the test bench is about to be completed. So thank you for listening to me. I know it took some time to explain my project and its flaws, and it's almost complete. I can't actually start the video all over again because of the time left to upload the video, and it's complete. The reason why I wanted to show you the test bench so much is that in the test bench the code actually works perfectly. Let me show you in this way. Most of the code doesn't mean because of the waiting times are higher than the processing time, but this part is where the processing occurs. And if we open the data, I set the test bench as to simulate the sensor sending 0 and 1 every time, and it actually works as intended, so I actually don't really understand why it didn't work in the real world. But thank you for listening to me, and I hope to present you a better project next time.